Okay, so welcome back, everybody. So for the next part of today's symposium, we're going to explore in a little bit more detail the current situation on science and engineering education in Japan, in Japanese higher education institutions, and start to think about whether the approaches that we heard about in Dr. Wieman's lecture are something that we want to, and if we could, introduce here in the Japanese education system. So I set up the Socrative system to get some feedback from you. As I did that earlier, it seemed that the University of Tokyo Wi-Fi network froze. So I'm currently connected to this through one of our administrators' mobile phone. But I can see that now a number of you have logged on, so I'm going to give you one more minute now. So this is just the first question is, have you ever had a teaching experience like that described by Dr. Wieman? Okay, so no, yes as a student, yes as a teacher, or yes as both a student and a teacher. Okay, so I'm going to give you now 30 seconds, and then we'll have a look at the results. And then I have one more question for you. And 3, 2, 1. Okay, let's have a look at the results. And what you can see is we have a very mixed result there, actually. So very similar to yes as a student and a teacher. Actually, quite a large number for both as a student and a teacher. So thank you very much. We're going to do one more question before we begin the discussion. And that's this one. So you should all be able to vote again now. Do you think an approach like that described by Dr. Wieman should be implemented in Japanese universities? A is strongly agree, B agree, C disagree, or D strongly disagree. While you're doing this, this is actually a system called Socrative, and you can use, if you want to try out the activities that you heard about, if you want to use clickers in your classrooms and you don't have any equipment, you can use this software completely for free as long as your class is less than 50 students. If you need a larger class of students, you have to pay for the licensed version, but this software is completely free up to 50 students. Okay, so let's take a look. How do we do? Okay, so the data's almost as overwhelming as Dr. Wieman's. It seems that virtually everybody in the room would like to see these kind of approaches implemented. Okay, so we may come back to some more questions for your feedback later in the discussion or not, depending on the direction the discussion takes. Thank you. Okay, so to now we're going to move to the panel discussion. So first of all, I'd like to introduce the members, the members that have joined us. So closest to me is Dr. Richard Shefferson. Dr. Shefferson obtained his doctorate at the University of California, Berkeley. Before moving to Japan, he taught at the University of Georgia. And he joined the Graduate School of Arts and Sciences as an associate professor in 2014. So, Dr. Shefferson.
Thank you. So just very brief, well, I had the little introduction there, but I just wanted to say what I teach specifically and what my interests are, which is that I'm an evolutionary biologist and an ecologist. And in terms of education, my primary interests lie in, first of all, teaching evolution to students, and also teaching critical thinking skills to students, because those are two things they are generally lacking in. And more importantly, also graduate student education. So how do we mentor the next generation of scientists?
Okay, so next is Dr. Ichiro Watanabe. He obtained his doctorate from the University of Tokyo, and he's a professor and former vice dean in the Graduate School of Arts and Sciences, and he's the current director of the Organization for Programs on Environmental Sciences. That organization runs the PEAK Environmental Science Program, which is the first undergraduate program in science at the University of Tokyo delivered entirely in English. So
Okay. Hello. Ichiro Watanabe. And my expertise is to molecular biology. And generally, I will teach life science in a very old-fashioned standard way. Many people believe that biology requires many knowledge at first. But listening to Dr. Wieman's talk yesterday and today, I realized that a more different way should be employed in the future, or I would like to try such new things. Thank you.
So next is Dr. Yuko Fuji Aki. She also obtained her doctorate from the University of Tokyo, and she's a professor in the Graduate School of Arts and Sciences, and she served as Vice Dean until March of this year. So.
My name is Yuko Fuji Aki. My major is STS. STS is the abbreviation of Science Technology Studies or Science Technology and Society. So my academic interests are social impact of technology, social responsibility of scientists, and science and democracy. Therefore, my research is relating to universality and cultural differences in relationship between science and society, and questions how to construct critical engagement by public for science-related social decision-making in Japanese society. For example, environmental problems or energy problems, including nuclear power plants. Thank you.
Thank you. Finally, we're delighted today to welcome Dr. Takatoshi Murata. He's the current president of the Physics Education Society of Japan. Dr. Murata obtained his doctorate at Kyoto University, and he was previously a professor of physics at Kyoto University of Education. Now, he's going to spend a few minutes telling us about the activities of the Physics Education Society of Japan, particularly about the interests in evidence-based learning. With that, Dr. Murata.
Thank you, Johnny. My name is Takatoshi Murata, and I'm very happy to be here, and I really appreciate for the invitation on this seminar. And I will briefly introduce the Physics Education Society of Japan as a president. Physics Education of Japan was established in 1952. It is a very, very long traditional society, and about 1,200 members, and 50% of the members are the high school teachers, and 33% is academic staff from universities and colleges, and 4% of students, and others are very small numbers. And we are publishing annual, academic journal every 3 months. And the title is Butsuri Kyoiku, which is the all in Japanese, the meaning physics education. And we have an annual meeting every year, and we have 7 branches, regional branches, from Hokkaido to Kyushu. And these branches have their own activity, and also including annual publication and the meetings. And also they organize the annual meeting every year. Annual meeting of the society itself. And this year, the Osaka people are organizing the annual meeting. And we had a very epoch-making international conference in 2006, and it is called ICPE 2006. And the ICPE is actually the abbreviation of the International Committee of the physics education, but also it can be read at the international conference, so ICPE of ICPE. And it's, but anyway, it was a very interesting conference, and we invited two plenary lectures. One is Professor Edward Radish from University of Maryland, and he gave a talk on the new direction of the researchers in physics education, underground physics education. And another professor was John Ogborn from London University, and he developed a very new curriculum in UK called Advancing Physics. And actually, I myself engaged in studying the advancing physics quite in deep. And also, we invited many active researchers and also professors who are doing the physics education research in the United States. And they organized the seminars and workshops and everything. And we are very much interested in that and influenced by that. And there was a strong, strong impact on the Japanese teachers. And then we decided to translate the book, which is called Teaching Physics in Physics Suite. And this was published by Professor Radish and widely read in the United States. And we translated it with the several members and published from Maruzen, this book. And actually, it was published first in 2012. However, now in 5 years, the 6th edition is already published, and this was sold very widely in Japan. And we studied this very, very deeply, and also we began to exercise and practice the method of the physics education research in many universities and also high schools. And if I have time, I will explain about the FCI and the CSTR. Those are the very standard way of testing or observing the present status of the students and the educational level. And so, I will leave this slide in the website of this seminar. So please refer to the references to those publications. Thank you very much.
Thank you very much. Okay, so we've received a large number of questions from the audience. It's going to be almost impossible, I imagine, to get through them all. So I will do the best job that I can. But just to begin the panel discussion, I wanted to start by asking, particularly Drs. Fujigaki and Watanabe, as educators and senior administrators at the University of Tokyo, what they feel are the greatest challenges and barriers to introducing the kind of substantial changes to teaching that Dr. Wieman has introduced. So if I could ask you to respond to that first. Thank you.
I was working as vice dean for 2 years, and before that, I was working as the advisor to the president of the University of Tokyo. So based on these experiences, I'd like to add 2 points. The first point is the applying active learning method to the education to the University of Tokyo. University of Tokyo have conducted education reform for these 3 years. We changed academic year from 2 semesters to 4 terms. And we also expanded one class time from 90 minutes to 105 minutes. In addition, we introduced first-year education program for science students as well as art students. So active learning method is already used in this first year education program. For example, in this program, the number of the students is less than 20, and students receive problem or project that should be solved, and they discuss each other and learn subject in active learning. So I thought the greatest challenge to introducing active learning method to higher education is number of students in one class, because that we already applied the active learning method towards the first year special program. However, for the ordinary basic class for physics and chemistry and biology, the number of the students in the class is so large, so we thought that it's very difficult to apply these kinds of active learning methods. However, Professor Wieman explained in his slide that active learning methods for 270 students. So maybe we were caught by the fixed thinking that active learning should be done in a small class, the class with a small number of students. So maybe one of the greatest challenges is the number of the students in one class. And the second point. This active learning method is constructed based on the questions with right answers. I mean that the students learn concepts through the questions with right answers. But I think that we hope this kind of active learning method will be applied to the questions without right answers. If we can apply to this active learning method towards the questions without right answers, these kinds of active learning methods will be used not only science education, but also education for citizenship in a more broader context of liberal arts and liberal education. In the last slide, Professor Wieman explained that the important point is learn, make decisions or make choice, and this is a very important point for the education of the citizenship. Thank you.
Thanks. I think it would be worthwhile, particularly the second point, asking for Dr. Wieman if he has an opinion on the idea, particularly of working with questions that don't have correct or incorrect answers.
Yeah, so, I mean, this is an important step to realize that the best questions never have simple right answers, actually. And so that once you convey that it's about really kind of probing the students' thinking and stimulating the communication and discussion, it's sort of a transition that the students and the instructor have to go over to understand. But once they do, actually, this works extremely well. And so, and so very oftentimes one can give a question, for example, like, which of these are the most important reasons, where they all are, important, and then it brings up the why, and then that goes into the discussion and the follow-up, and much more productive learning than actually if you have questions which are sort of very simple and factual. Those never are as effective. So it's just a question of understanding how to ask the right kinds of questions and how to present them to the students so they're comfortable with the way they're being used. But yeah, in my classes, I always think the best questions are ones that can be quite ambiguous, and depending on what you think is most important, you'll have a different answer. Those always generate the most deepest thinking and discussion.
Okay, so Dr. Watanabe, are there additional comments you'd like to make from a kind of an administrative point of view?
Okay. Introduction of this kind of system will be challenging for our university, mostly for, say, life scientists, as of course. Actually, maybe we have to convey students what is important and what is message in this class. So for that purpose, we can develop such strategy to insist on such message. So we are now trying to find out what's the best way.
Thank you. So related to this issue, actually, we had a question from Takuya Okuda in the audience who said that evidence-based science education seems to require more resource. Each faculty has to spend extra hours to learn the teaching method, and in a background of a cut in the budget for higher education, how can we overcome those challenges, and how do we convince not just educators but politicians, bureaucrats, and the public that this is worth investing money in to change? So if anyone on the panel would, yeah, Dr. Wem.
So this issue about the demands for resources, this is something that at the University of British Columbia, where we launched this large initiative changing we looked very explicitly at the question of the costs. And what I can say is that, I mean, we have clear evidence that you can implement these methods without any additional cost. That with the same resources and the same, classrooms, etc. The one thing that is different is the time the faculty have to be invested in learning to teach this way. So, you could imagine, as strange as it may sound, you could hire faculty who actually know how to teach before you hire them. That's supposed to be a joke. But if you don't, but your current faculty, like I say, and I mean, there is a real cost of, you can imagine, it's something like an extra 50 hours. Now that's, that's not zero, that's a significant amount, but it's not enormous compared to the amount of time a regular faculty member puts in each week. So, that, and in fact, it's quite small compared to the overall benefits.
Yeah, please, Tamara.
Well, in the physics education field, as long as I know, in the United States, the physics education is one of the academic field of in physics, and Physical Review magazine has the specified part of the physics education in online journal, as an online journal. And there are many physics education physics education section in physics department. And many young people are trained in a very new physical education technique in that field. And they go to other university to be a physics teacher in the university. So I really envy the situation in the United States, that they are already established to educate the educator in systematic way.
Okay, thank you. On this issue, well, I think probably we'll discuss a little bit more before I involve the audience. I'd like to move to Dr. Shefferson. Dr. Shefferson has worked, teaching in the U.S. Education system, and also for a while now in the Japanese education system. So I wanted to get his perspective on what his views are with regard to this.
Well, yeah, so I used to teach at the University of Georgia, which some of you might be aware of where that is, but that's within the American South. I taught evolution in the American South. Some of you might know what that implies. And so I am first and foremost a biologist, I would say. I was trained in biology. It's my passion. So I wanted to teach that very strongly. And what I discovered, even though my background as a student was going to lectures, was that really my students would come, and there were days that they enjoyed my lectures, but I still, at the end of the semester, when I gave them a test and asked them what natural selection was or what are the methods of evolution, they really didn't understand. And the thing is that it's not simply a religious issue. I mean, to be honest, some of the really, really Christian students who didn't believe anything about evolution would actually get the questions right. There was something more going on. And so I experimented with active learning for that point. Because, so one of the things that active learning is good for is for trying to get students to unlearn maybe concepts that they think they understand but don't, right? And then to relearn them in a better way. And so I found doing that their comprehension of evolution did improve. Now, in coming to Japan, so I've taught both international students here as well as Japanese students. And there are sort of two issues that come up. One is that there is sort of a cultural difference among students, right? So if I teach in the US, I teach in a particular way. That doesn't really work here, okay? So you have to change. The way that I deal with students, for example, how I approach them. I don't want them to feel like they're on the spot or anything, so I have to try to drag answers out of them in different ways. That's one thing. But another issue is identifying what it is really within their thinking that might be a hindrance to learning a new concept. And so I work a little bit with trying to put in active learning into my own classes. But that's done well when you really consider what it is that they don't know. And coming to Japan, I don't really know what it is they don't know. What is it that they think they know that they don't? Now that turns out to vary culturally as well, and so then when you teach an international program, it gets even worse because your students all have different blind spots, right, that you have to teach to. So those are the difficulties. But I do have to say that I don't think there's like structural hindrances per se within Japan to doing this. It comes down to the fact that we're all way too busy for our own good and don't know how to do it. So we do it as we get the time to learn how to do it and to figure out what to implement where.
Would anyone like to address?
Yeah, if I could just make a quick comment on that. I mean, in the interest of my talk, I had to sort of leave out lots of important things. But when I see these kind of active learning, interactive teaching, they really are accomplishing two different but equally important things. So I really focused on what the learner is thinking about. But Rich has made the point that's equally important, which is they also help the teacher understand much better what the learner's thinking is, and so they can build on and support and connect with that, which is, as I say, absolutely equally vital. So I'm just kind of very happy that he's made that point, because it is a very critical element to making this kind of teaching successful, is how well it helps the instructor better understand the learner, because that's so critical to being effective.
So actually, on a very related point, one of the questions from the audience was how do you get your students to, and I guess this is really referring to Japanese students, how do you get your students to actively get engaged in in-class discussions? I find it difficult to put this kind of method into practice because most of my students are too shy to discuss with their classmates. Now, the audience sound makes me feel that that's not an isolated problem. I mean, it's certainly anecdotally true. Would anyone on the panel I should also point out at this point that the panel members are also free to answer in Japanese. We have the translation. So, is this widespread amongst the audience? Those of you who teach Japanese students, do you find challenges in getting the students to be involved in discussions with one another? Can I see hands from anybody? Raise your hand if this is actually a part of the problem of your teaching. Okay. Yeah, I'm going to hand over to Rich. Actually, quite a lot of hands went up there.
I'm just going to make an observation that's probably wrong, but I'm going to make it anyway. So I've seen how the lab practicals work within biology, for example, which I'm not a part of that group, but this is the way the normal Japanese students at Todai have to go through this in their first or second year, I think. And I've seen how that works. And I've also seen how the Alessa and Alessa programs work a little bit within classes where the Japanese students have to go into an environment where maybe they have to do a scientific study in a small class, right? And what's always amazed me is that when the students are in those environments, they're completely different than in the lecture. They're actually interacting quite a lot with each other and with the professor and other instructors going around. And so there's something to be said for putting the Japanese students into small groups where they're doing tasks. There's something to that, definitely.
I think in the audience we have a number of members of faculty here from our ALES and ALESA programs who are teaching, in ALES certainly using a kind of scientific context to teach English to University of Tokyo undergraduate students. And as far as I'm aware, many of those classes involve students discussing amongst themselves in small groups. I'm seeing some nods. So do we have the microphones available or not? Do any of the ALES or ALESA faculty have any comments they'd like to make on whether this is something that they've experienced or if they have good methods for for encouraging the Japanese students to communicate effectively with one another?
I mean, there's a bunch of us here. I'm kind of an ex-ALICE teacher now. But one thing about having a class of 15 students is they definitely can't hide. I mean, you are there, and I can sit in the middle of a classroom and I can eavesdrop on all their conversations at the same time. I mean, I liked, you talked about walking up and down the aisles, and I think, I'm not sure, I haven't really taught large groups of Japanese students. I don't have experience with that, but I think in some ways with large groups it's easier for students to disengage, kind of opt out and kind of hide, and then when they see you approaching they can maybe try to look like they're talking. So I definitely think for Japanese students the small classes are definitely beneficial. Anything you guys
thanks.
want to add?
Okay, so is there would any of the panel have any responses? Yeah, okay.
Well, actually, I already retired. I'm not engaged in the education by myself. But I know a young professor who is doing the active learning, who is applying the active learning method in his class with 40 students. And he is doing every time, all the time, for half a year, for 40 students. In the first year of physics experiment class. And his way of teaching is that he first declares that this is not the traditional way of teaching. And you have to involve in the class actively, he first declares. And of course, at first, students are very shy, and they don't engage in the class very eagerly. However, in 2 or 3 days, hours, they began to be active very, very strongly, and they show their opinion. So one thing which is important is that you have to make the student understand that the way of teaching is different in this class. If the professor is doing the traditional way and just keeping the student active, it is not successful. I think the way of teaching of the professor is very, very important. So in that way, the education of the educator is very essential to promote the active learning.
Thank you.
Can I?
Yeah, please.
So this issue about how the students would respond to it was something we were very concerned about when we went to the University of British Columbia, where it has a big range of different students, but it's majority Asian, with the largest of those being Chinese, often first or second generation, but a whole variety. And there was a lot of concern about this same issue, that they felt that in particular the Japanese and Chinese students, which are a substantial number, wouldn't really participate. But we found it really wasn't nearly as big a problem. I mean, it's just like Dr. Murray says, is that it was really a question of faculty need to learn to change the norms of the classroom, and so that it, and with rather quickly students would understand, no, the classroom was about them talking and communicating, and there were very explicit things people would find to sort of reduce essentially the social discomfort of people to contribute. For example, calling on groups to respond, not as individuals, but having the student to represent their group, as opposed to having to be individual. Little things like that you do routinely, and we found that actually they became quite comfortable. And in later studies, we found that it was actually the groups that were the least vocal and interactive in classrooms who were then finding this value of teaching the most valuable, that everybody liked it, but the ones who, in particular, I remember the Chinese women, first generation Chinese women students who traditionally never interacted in class at all, were the ones who sort of expressed the greatest appreciation for these teaching methods. So it was quite interesting to see, but I think it's the same basic point as you can't just tell the students what to do. You have to take them in as kind of partners in this approach, and then it can work.
So we've actually received quite a number of questions on sort of the actual method itself, as we might imagine. But there are some sort of common themes, which I think worth exploring some of these. So actually, two professors, both from the University of Tokyo, wrote about one issue. So I'll read both the questions, actually. Particularly in maths and physics, professors usually say, thinking like a scientist is not possible for undergraduates because they lack basic knowledge. In that sense, do you think a combination of traditional lectures and these kind of approaches is critical? And the other question said, that you mentioned, that Dr. Wieman mentioned, that factual knowledge is a basic component of expert thinking. I'm wondering if this is a limiting factor in teaching scientific thinking to undergraduate students who do not have a lot of factual knowledge in specific subjects. So maybe to begin with, Dr. Wieman, could you maybe, do you have I'm sure this is a question that you've been asked before.
Yeah, so I mean, the basic issue here is that factual knowledge and scientific thinking, you really can't be separated. Can't separate them. You have to learn the knowledge as a way to solve problems and answer questions, and so they really have to come along together. And I think we see very consistently that once people become experts in a subject, then they look back on it and think, oh, the way to learn this is you learn all these facts and then you learn to use these facts. And that's just not the way the brain learns. The brain learns from here's a problem I'm trying to solve, here's a decision I'm trying to make, and then you learn best by going and learning and figuring out how to use knowledge connected with that. And so I would argue that this is very consistent of a perspective of people who become experts think, see this would work best, but it's just not what the research shows. The research shows is that, and even at starting with very limited knowledge base, you have to be thinking about how to use that knowledge, it takes little steps to become an expert, but it's both steps of knowledge and scientific and kind of cognitive processes at the same time.
Does anyone have any responses or points they'd like to make? No? Okay. So I think I'd actually like to, at this point, refer, when Dr. Wieman kindly, as he said, gave a talk about this topic yesterday to undergraduate students from the perspective of, as students, given this knowledge, what should you best do to improve your ability to think like a scientist or whatever it might be? And one of the questions that seemed particularly pertinent with respect to certainly the University of Tokyo context and maybe in other universities was the fact that the University of Tokyo has students take very, very large numbers of courses. Okay, so I think at the moment the typical number of courses taken simultaneously by a first-year University of Tokyo undergraduate student is typically 15 courses in one semester. And so I think I wanted to get the panel to talk a little bit about this issue because from Dr. Wieman's comments yesterday, his view was that doing this kind of teaching approach for students simultaneously studying 15 courses in one semester is simply untenable. So I'm opening up that question to the panel to think about. Maybe you can all have a think for a moment. I kind of sprung that one on you. Maybe can we switch on the thing? Maybe we can find out from the audience what you think and how many classes should undergraduate students take during a semester. Okay, so if you wanna vote on this, what do you think is the optimal number of courses that should be taken by a student in a Japanese university in one semester? 3 courses or less? Between 4 and 8 courses? Between 8 and 12 courses? And more than 12 courses? And it looks like at least the connection's working all right, so we're getting some responses. Okay, it seems to be slowing down. Just another few seconds. I think we'll pick this question apart a little bit because clearly it's not the case that what we've heard about learning to think as a scientist and achieving these skills is not the only single thing that university education is about, and there has to be some balance within there, and the philosophy of different universities has different goals. So maybe we can explore this a little bit. So let's see, how did we do with this? So it seems that I guess we have, we have professors and students in the room, but it seems that the middle ground, much as Dr. Wieman said yesterday, is probably a good choice for here. So let me first ask Dr. Wieman, is this feasible with 8 courses? Is this feasible with 12 courses?
I'm going to say I don't know.
Okay,
it's just an area. We do know there's sort of limited capacity of the brain to deal with the number of new things it has to try and process, and so, but exactly what that mean, I can't
in the
say with
context that you've
authority,
studied,
so,
for example,
yeah.
in British Columbia and so forth,
Right,
what's
right.
the typical number of courses that students take in those environments?
I would say 4 or 5 would be maybe as much as 6, but that's pretty usually considered excessive. Yeah.
Okay, so
Yeah, sometimes engineering has 6 or 7, but most people think that's a mistake. So I'm curious, have they ever polled the students here and get an idea of what if the students think this is excessive or not?
interesting. Does anyone? Do you have any comments or? Yeah.
I think our University of Tokyo has priority principle to have general education in the first and the second year. So that urged us to provide more lessons than proposed here. So other than that, it's quite realistic to learn in deep, in focus on particular issues.
I mean, it would seem, as far as I have kind of, since I came to the University of Tokyo, my view of this is that there is this model, so that in the first and second year of students, the goal is not actually that there's a belief, as we heard in the other questions, that students don't have enough knowledge to be becoming expert thinkers there, and that type of learning actually happens later in the cycle in Japan. Maybe happens in the senior division in the third and the fourth year, and maybe in the master's degree. And that's to some extent reflected, I think, in exit point from Japanese universities. Many students obtain master's degrees before going into employment, for example. So I wonder if this were to be something that we want to think about in this university, then maybe it's something that could be explored certainly in the first instance, later on in the cycle. I would like to hear the responses. Does anyone agree or disagree?
So I have to say I'm slightly confused by the question, because it sounds to me like there's actually 2 issues here. One is, are there too many classes that students have to take? And the other is, does active learning work when you take a lot of classes? Which I think are 2 totally different things. It seems to me from everything that I've read, I don't know if there is data on students taking huge numbers of courses and doing this. But the point of active learning is to learn something very, very deeply, right? And I don't see why you couldn't do that in 15 courses. I mean, you would probably learn that material better, although you'd still complain you were taking too many courses. So there are 2 different issues. So restructuring the program, I think you could still get your liberal arts education in 2 years with all those classes doing this. But probably a different question needs to be asked, which is how would you restructure it to do fewer courses if that was the idea? I mean, from the US system, we offer liberal arts educations with far fewer courses, but you have to bear in mind that we meet many more times. Contact hours for me for a single class in University of Tokyo would be about something like 23 hours or something like that total, right? Whereas in a US class, the minimum would be 45 contact hours in a semester. If I was doing lab or discussion, it'd be 60 or 75, right? So I'm meeting with the students much more in the US per class, and that's a very big difference. Here, sometimes these classes get split up. To me, one biology class gets split up into 2 or 3, for example, right? So I think there's a sort of a more practical way of viewing this. They're still taking much more than US students would, or probably English students, and that's a separate issue, I think, that needs to be addressed as well.
I think probably it's worth maybe asking Dr. Murata at this point. So the data that we've looked at and the data that's been presented is from this context of North American context in which classes are, there's a typical model to the number of classes taken by students per semester. And so there's a more general question then, I think, about what evidence has been collected and what evidence is being collected on Japanese students in terms of so doing the kind of measurements and experiments that Dr. Wieman described, but with an audience of Japanese students rather than North American students. So, Dr. Murata, maybe you could speak to that.
With the JSPS fund, and which is very interesting. We had a very interesting result, and it's very small. And I will talk very briefly on this on the project. And the title is "The Investigation of the Present Status of Physics Education in Japanese High Schools and their Colleges." And we want to check the level of the the attainment of the physics education in Japanese high schools and colleges, and investigation of the levels of scientific reasoning is also done, and we use the verification of the investigative tools developed by the Physics Education Research, which is FCI, which is Force Concept Inventory, and also the classroom test of the scientific reasoning developed by Lawson. And this project is 5 years plan for 2014 to 2018. So this year, this is the 4th year. And we did the investigation in very many universities and high schools. For example, for force concept inventory, we checked about 7,000 altogether for high schools, and also colleges for about 5,000. And also the Lawson test. This is a Japanese case, Lawson test, classroom test, which I will explain a little bit later. Japanese case is, the number was about 1,000. And there is another investigation by Bao in the United States, about 1,000. Also China, 370. And which is very interesting is the average is almost the same, and also the standard deviation is almost the same, which means that this way of investigation is very applicable with the different cultural background and also so. Okay, the FCI, this is the force concept inventory, and this was developed by Morris in 2006 and revised in 2012. And the result shows the tendency of the selecting false answers and of the testees. And not only the right answers, but the false answers, the tendency of the false answers. And we found a very, very strong correlation between the responses of the Japan and US. So this shows the validity of the FCI independent on the cultural, regional differences. And also this shows the validity of the method of the analysis used in the physics education research. Okay, this one, sorry in Japanese, but this is very simple question used in the FCI. And this figure shows the pack sliding on the frictionless floor from left to right. And this picture was taken from upward. And at the point B, with the same speed, of course. And at the point B, this pack was hit to the upper side. Then afterwards, the question is that what is the force after the hit? Force on the B after the hit. And the selection of the answers is first only the gravity. The second, gravity and the horizontal force, which is on the direction of the movement. And the third one is force of the gravity and also the force from the floor, and plus the force of the going to the the horizontal force. And then the fourth answer is the gravity plus the force by the floor. Which one do you think the right answer? Okay. Anyway, this is a little bit complicated graph, but this is called the item response curve. I will not explain this in detail, but the horizontal line, horizontal scale is the total score, and the vertical one is the percentage of the answers. And the student who took the full score, which is 30, the 100% of the right answer. Black triangle is the right answer, which is answer 4. But there are many strange correlation between the other questions. Okay, which is very interesting is that on the same question, the right figure shows the result of the United States, and the left one is a Japanese case. And you can find a very, very similar shape. The cultural difference and also the regional difference is very strong, but still the tendency is very similar. And so in this way, we found that the way of investigation using this tool is very effective to analyze the present status of the educational status, especially in the physics education field.
Okay, thank you very much. So I think that it seems that there's definitely lots and lots of good reasons to believe that this kind of approach could work equally effectively in Japan in the right context. So actually, I wanted to ask Dr. Wieman, really now, from and I think you've done some studies on these things, within different groups of students, whether that be different cultural backgrounds or gender or those kind of issues, does this seem to work for all students? Are there some student groups that benefit more, or do you have any data or anything you can comment on that?
There's actually a whole variety of things that we've looked at and others have looked at, but recently we've been studying more the student sort of, let's say, comfort level and sense of belonging in the discipline, tendency towards want to pursue the discipline, and how that and their performance in the classroom across very different demographic groups, which, as most of you know, there's in the U.S. much greater variety, and we see that, for example, African Americans who are traditionally have very few going into science, particularly going into physics, if you measure their performance in a physics class with all the equal preparation, they'll score lower, they'll be less comfortable in the class, and so on. And it's sort of, and it just is true across all different, all different groups who are sort of traditionally not representative in that. And so we see similar things with women in fields that there are very few women going into, and students. And so so what we recently and some others have just started doing is studying how the change from the traditional instruction to this kind of active learning impacts some of those performance differences across different demographic groups and some of these attitudinal differences. And the early results show quite striking effects, that these things where the different groups were performing differently in the traditional course, with the underrepresented groups doing worse, those effects have gone away when people, so they're just changing, they're still testing the students, evaluating in the same way, but the students' performance is going up, and also then their comfort level in their measures of confidence they could succeed in this subject, and their interest in pursuing this subject seem to have actually also made major changes. Now, I want to emphasize, it's not that it's just changes for this group. All the students change, but it's ones that where they're representing groups that are historically performed worse, been less represented in this field, seem to have a larger impact on them. And so, but this is an area in which it's sort of much newer, and we're studying details about understanding why and how these benefits happen, and we really don't fully understand. There's a lot of questions we still have about that.
Thank you very much. Does anyone have any comments they'd like to make? Shall we move on? Okay. What I'm going to do is maybe have one or so more question from those that are submitted, and then maybe for the last 10 minutes or so, I'd like to try and now that you've had a chance to listen to some of the discussion, I'm going to take some questions from the floor. Okay, but given that this symposium is kind of organized by the Global Faculty Development Initiative, there was actually a question about faculty development from Tohoku University, and it raised a very interesting question that I'd like to put to Dr. Wieman. So, it says, please discuss the issue of faculty development based on what Professor Wieman talked about. For example, how effective is student satisfaction survey on a course an indicator of teaching excellence? So I think it's very common in Japanese institutions as well to use student surveys as a means of convincing ourselves that we've done a good job. So maybe I can ask Dr. Wieman to speak on that first, and then talk to some of the other members of the panel.
Yeah. So this is an area where I can well believe that different students in different countries could be quite different in how they respond. So I will preface my comments to looking specifically just at North America. There's been several, particularly recently, fairly rigorous studies of these where they look at, so I know studies that have looked at the student evaluations against how well those are correlated with the actual amount that students learn, and basically they aren't. And they really can't be, because to give a good evaluation of how much you learned in a class, you have to know how much you didn't learn in the class that you might have. And that's an awfully that's impossible for people to do. So they don't have much correlation with learning. And they also don't have a correlation with the use of effective teaching methods. And this is something where probably the best data on this is from our work at Colorado and British Columbia, where we have a couple of hundred faculty who have changed very drastically how they teach. In many cases, we have good data showing the students are learning much more. But basically, what we see is the student evaluations of the faculty member don't change. That those are really kind of locked to the faculty member's personality and whatever other traits students are choosing, but not dependent on the teaching method. So those are the two things that we know that make teaching student evaluations rather problematic from thinking about improving instruction. Like I say, it could well be that Japanese students have different perceptions and decide on different factors when they're evaluating, and so I would be quite hesitant to make claims that those apply to Japan. I think you have to study that yourself.
Does anyone else have any? Yeah, please, Dr. Fuji.
Based on the experience of designing the student evaluation, there are lots of there are a variety of the students' evaluation according to the evaluation design. I mean that, and at the same time, there's also differences in the goal of the class. So I think the matching between the design of the students' evaluation and goal of the education, that kinds of matching effects on the results of the evaluation. So, for example, what is the goal of the class? Amount of knowledge acquisited in the class, or how to get the thinking ability during the class, or do you learn a method for making decision or choice, as Professor Wieman pointed? These kinds of difference of the goal of the class will affect on the results of the students' evaluation.
Thank you. I wonder when you, Dr. Wieman, when you develop these, when you train new faculty or graduate students to use these teaching methods, what other kinds of support mechanisms exist? I mean, is it common to evaluate to capture information in those traditional ways, or do you not do that kind of thing at all?
So, I mean, I really have done much more research on the students and student learning. We have looked at sort of what things faculty have to do to make them successful, and how, for example, on student evaluations, how they have to present it to the students so the students are more comfortable, et cetera. And but in terms of sort of systematically understanding and researching faculty and their learning of these things, I don't really think I can give you any, expert
Sure,
views.
but in these contexts, those students are still filling in standard student evaluations?
Oh, yeah. So in the work we've done, particularly British Columbia and Colorado, students are still, the same evaluation system is in place. The students are still filling out the standard evaluation. So we had to pay a lot of attention to make sure that, if the student evaluations went way down, it would have been a disaster. So we systematically looked at what sort of things could make students uncomfortable with these methods, and the big factor was if they felt that the faculty member was doing experiments on them, and so it was really important the faculty introduced these methods by explaining why they were using them, showing them some data, showing this is beneficial and being done for the student's benefit. So, and then we would regularly have the students sampled and have discussions with them. And I could say that's part of evaluating the faculty member. It's also part of just being good teaching, is making the students more partners in the operation. So you have a discussion with them on an ongoing basis about how this is working for them, what things they're uncomfortable with. Sometimes those are things you're not willing to change because they don't know. And other things are quite useful to know and change according to what's beneficial to the students, and you can teach better by listening to them. So,
thank you. Okay, so as we draw to the end of this discussion session, I'm going to we'll have some people with microphones. So if anyone has any questions, particularly on items that have come up or things that haven't come up that you think should have come up, maybe you can raise your hand and we can take a couple of questions from the floor. It's coming.
While he's getting a microphone, I have to make one comment of people raised the concern about Japanese students being uncomfortable talking to each other. In my lecture yesterday, Japanese students, I gave them a chance to talk to each other, and I was worried no, none of them would do it. In fact, the room was filled with noise. They were all talking very eagerly about it, in part because it was an interesting question we posed to them. So, I think to me, that was a striking event.
So let me introduce a trial of the first year seminar in Tokyo University. So we have a faculty development before for the professors before they are having the class. So actually we try to experience the group works for professors. That's very effective for they have experienced and they will learn the student mind. And actually, we have opened 100 classes, and after the classes, we have evaluation by student and also as well as the professors. And actually, the students are actually satisfying the class with they are actually enjoying the active learning, because the purpose of the class is actually we try to change the attitude from teaching, from learning by yourselves. And professors are feeling that they have actually succeeded in changing the student mind. So, but still, professors once experience, they recognize this teach of method is very effective, but the rest of professors still doesn't recognize like that. Yeah, that's my comment. Thank you.
Actually, one of the questions that I received was about what incentives can we provide for this change. So if anyone has any comments in the audience or in the panel, yeah.
So if you think about what it means to be a university professor, chances are you're really passionate about some form of research, whatever it is. And so the incentives that you come up with have to take that into account. So within the U.S., for example, it's been sort of realized that it's very difficult to do that. So in a lot of universities, we have, departments will hire teaching faculty that love a particular subject, but decide that their passion is to teach it and to do pedagogical research, and so they fulfill this role. That kind of split is unfortunate, though, because it means that there's a lot of faculty that still teach that, don't go through that training and don't necessarily change. So there have to be some incentives put into place so that you can slowly over time transform your courses, I think, is what needs to happen. Those of us who are doing this, actually, as I said, we're taught in lectures. So it's not like we naturally go to active learning. We have to learn it, and then we have to think about how to redesign our classes, which is a lot of work.
I think I'd like to take one more question from the floor, if there is one, just to finish things off. See, now there you see, actually, it seems that Japanese students are very happy to ask questions, but Japanese professors less so. Okay, one last question.
I'm actually just very curious. You mentioned in your lecture that most of the feedback you have on your classes, the redesigned classes, is very positive, but there's 4% negative comments. What do students criticize? Like, what are some things that students don't like?
So, 4% is a very small fraction. In fact, it's such a small fraction, we can identify who the student probably is, even though it's anonymous. And basically, it's a very, the instructors have said, it's a very unsociable student, a student who just doesn't like to interact with people. And so they are uncomfortable with the fact that in this, they're expected to talk with other people.
Can I have a quick follow-up question? No, it's okay.
Okay, so with that, it's now time. So I'm going to bring the end of today. I'm going to bring today's symposium to a close. So could you join me in thanking, of course, Dr. Wieman and also the other members of the panel for what I hope was a very interesting discussion.